Let's begin with a simple yet powerful concept, the center of gravity. It's the specific point in a body where the entire weight seems to act, regardless of the body's orientation. You can think of it as the average location of weight. If you support a body exactly at this point, it will remain balanced and not tip over. For some objects, like a ring or a hollow sphere, the center of gravity may lie in empty space. It's all about how the mass is distributed. Now, what's the difference between center of mass and center of gravity? The center of mass is a purely geometric term. It refers to the average position of all the mass in a body. Center of gravity, on the other hand, takes gravity into account. Near the Earth's surface, both points usually coincide because the gravitational field is uniform. But in large or distant objects, like satellites in space, the two can be different. This subtle distinction becomes important in astrophysics and advanced engineering. For regular, symmetrical shapes, the center of gravity is located exactly at their geometric center. In a rectangle, it lies at the intersection of the diagonals. In a circle, it's at the center point. For a triangle, the center of gravity is found at the point where the medians intersect, that's 1/3 the height from the base. This makes it easy to predict balance in everyday objects like furniture, frames, and tools. What about irregular shapes? For these, we use experimental techniques to locate the center of gravity. One common method is the plumb line method. Suspend the object freely from one point and let a string with a weight hang vertically. Draw a vertical line along the string. Repeat the suspension from a different point and draw another line. The point where these lines intersect is the center of gravity. This simple method is often used in lab experiments. The position of the center of gravity affects how stable an object is. A low center of gravity gives more stability. That's why race cars are built close to the ground. If the center of gravity is high, the object is easier to tip over. Think of balancing a stick vertically versus horizontally. Also, a wider base helps keep the center of gravity inside the base area, preventing tipping. This is key in designing safe furniture, towers, and even robots. Let's take a simple example. You have a uniform triangular lamina, and you're asked to find the point where its weight acts, its center of gravity. We know that in a triangle, the medians intersect at a single point, and that point lies at 1/3 the height from the base. So, the center of gravity lies at the centroid, the intersection of the medians, and that's where the entire weight effectively acts. To summarize, the center of gravity is the imaginary point where we assume the total weight of a body acts. For symmetrical objects, it's at the center. For irregular ones, we find it through experimentation. The lower the center of gravity, the more stable the body. Understanding this concept helps us build stable structures, design safe vehicles, and predict balance in everything from cranes to coffee mugs.